Chapter 8, Section 10 in the 7th grade note-taking guide is entitled Translations, Reflections, and Rotations. So what we're beginning to talk about here now are geometric transformations. There's actually another one which is its own section, and that's called the dilation. Why these three are together and that one is separate is because when we're talking about changing a shape, these are the three that do things to the shape that doesn't incrementally change its size. It doesn't change the area of the shape. Whereas the dilation is the one that actually will change the size of the shape. It will change the area of the shape. But these three don't change the area of the shape. They do other things to the shape other than that. And so that's why these three are grouped together here in Chapter 8, Section 10. So what is a transformation? It's a change in the position or orientation of a figure. So if we're talking about things in terms of the coordinate grid, which most of your questions will be here today, we're talking about where the shape is on the coordinate grid is going to change, or how it's laid out on the coordinate grid is going to change. Now, we've got a couple terms that describe what we actually have here. The image is the figure resulting from a transformation. So that's like the after, and the pre-image is the original figure in a transformation. That's the before, what you started with. So you're going to start with the pre-image, something that's laid on top of the coordinate grid, and then you're going to do something to it, one of these geometric transformations. And when you're done doing whatever to it, that's called the image. Alright, so let's go ahead now and take a look at the next set of definitions here towards the bottom, because now they're going to give definition to the actual transformations. Translation, that's a movement of a figure along a straight line, and that's sometimes called a slide. A movement of a figure along a straight line, sometimes called a slide. Now, when they're saying straight line, what they really just mean is a line. You can take and move the shape any way you want on the coordinate grid. You can slide it left to right along the x-axis. You can move it up or down in terms of the y-axis. You can move it diagonally, however you need to, but it's a movement along a line. A reflection is a transformation of a figure that flips the figure across a line, and we'll actually end up spending a lot of time talking about reflections because there's a whole section on symmetry, which is all about reflections. But again, it's just a transformation of a figure that flips the figure across a line. If you're thinking of your mirror in the morning, you're thinking of the exact right idea here. The line of reflection is the line that the figure is flipped across to create a mirror image of the original figure. And a rotation is a transformation in which a figure is turned around a fixed point. So that's me taking and turning a shape somehow, but not making any other changes to it. Again, a rotation is a transformation in which a figure is turned around a fixed point. So as we go ahead and take a look at what we've got here at the bottom of the page, they're simply asking me to identify each type of transformation. So your choices here again are what you saw in the definitions. A translation, when we take and slide a figure. A reflection, which is when we create a mirror image of a figure. And a rotation, that's a transformation in which we turn a figure. So as we look at A here, clearly this is a reflection. They're creating a mirror image of the figure over the y-axis. You will see that they will, in this book, in this 7th grade book that is, create reflections usually over the x and the y-axis. Truthfully, it can be over any line. If they want to reflect it over the point where y is always 2, y equals 2, they can. But usually they'll focus on the x and the y-axis here today. This line that they're creating the mirror image over is called the line of reflection, which we defined in the definitions here today, so it's important for us to know what that is. That's simply the line about which we create the reflection. Notice in terms of that line, everything has the same perspective. For instance, this point down here at the bottom, all right, is 1 away from the x-axis to the right, and in the mirror here, it's 1 away to the left. And we could go figure that out all the way around. It's going to be the same. This point up here is 2 away to the right, and the other it's 2 away to the left. This point up here at the top is 4 away to the right. In the mirror, it's 4 away to the left. And again, that's going to be true all the way around. It's got to have the same aspect ratio in terms of that reflection. Taking a look at B, B is clearly a translation. They've taken and slid the figure. That's all we have to identify here. They will talk about writing it in terms of coordinates, how we moved it. You can talk about that in general. You know, take a look at the x values if we're talking from here to here to get from this triangle to this triangle in terms of the x values. As you can see, the whole thing has been slid 1, 2, 3, 4, jumps to the left here. I'm sorry, 1, 2, 3, 3 to the left here. I'm looking at this B point here, going from this B point to this B point. You've made 1, 2, 3 jumps to the left here. So in terms of the x-axis, we're subtracting 3. And then you could figure out the same thing for the y-axis. In terms of the y-axis, to go from those same points, you went 1, 2, 3, 4 down. So we're subtracting 4 there, and that same set of numbers is going to work for every set of points here. These points that are in the upper corners and these points that are in the lower right corners, it's true for as well. Alright, so let's go ahead and continue on here. Example 2, we're supposed to graph the translation of quadrilateral ABCD, 4 left and 2 down. So this is a translation, what we were just talking about. Again, what that means here is that every corner, every vertex is going to go 4 left and 2 down. And that's exactly what we're going to do to draw the figure here. There's no trick to this. There's no quicker way to do this. You literally have to take the time and count this out and move the shape around. So if we start with point D here, this is the pre-image, the before, because it's obviously already on the graph. We're going to take that point and move it 1, 2, 3, 4 left, and 1, 2 down as the directions said. I'm going to take the A point and do the same thing. Go 1, 2, 3, 4 left, and 1, 2 down. And there's my new A point. I take the B point and go 1, 2, 3, 4 left, and 1, 2 down. And there's my new B point. At the C point, I'm going to go 1, 2, 3, 4 left, and 1, 2 down. And there's my new C point. And I connect the points. Notice the shapes look the same because, well, I haven't changed them at all. It's just me redrawing the shape in a different location. And that's all there is to it. That's all a translation is. Notice it doesn't change the shape in any other way. It's not being churned. That would be rotation. It's not a mirror image here. All we're doing is taking and sliding the figure around. So as we go ahead and take a look at example 3 here now, in number 3 we're asked to graph the reflection of the figure across the x-axis, and then we're supposed to write the coordinates of the vertices of the image.